Students, the next terminology or term what we are going to study in this coordination chemistry is coordination polyhedron. What is coordination polyhedron? In this module you could see 5 different types of polyhedron. Already we studied coordination sphere. So in this coordination sphere there is a central metal ion ligand, right? This can be represented in the three-dimensional form and gives you a picture about this coordination entity. That is called what? Coordination polyhedron. So in a coordination entity, the solid figure defined by position of the ligand atoms directly attached to the central atom or ion is known as what? Coordination polyhedron. See, there is octahedral. Octahedral, you can see central metal ion occupies a central position. See, 4 ligands are placed at the 4 different sides of the 4 different sides. Above the plane there is one ligand, below the plane there is one ligand. This is called as what? Octahedron polyhedra. The next coordination entity what we are going to see is tetrahedral. Tetra means what? 4. 4 ligands are occupying. Okay. This is tetrahedral. Next one is square planar. Square planar. See, in this square planar, central metal ion is placed at the center, but the ligands are occupying the corner position of the square. Okay. So this is square planar. Next one is, the example is given for this. So for octahedral, hexamine cobalt 3 plus ion. Cobalt is placed at the center. 6 ammonium ion is placed in the 6 different direction. You can see tetracarbonyl nickel. See, nickel is placed at the center. Carbonyl group, that is carbon monoxide, is placed at the 4 different sides. Tetrachloridoplatinate is an example for square planar complex. You can see this polyhedron. See, the next terminology what we are going to study is oxidation number. Oxidation number is nothing but the oxidation state of central metal ion. See, if all the ligands are removed from the complex, the central metal ion possesses a charge, no? That charge is called as what? Oxidation number. The oxidation number of central metal atom in a complex is defined as the electric charge it would carry if all the ligands were removed along the electron pairs that are shared with the central metal atom. The oxidation number is represented by, you can see the metal, and the oxidation number is represented by a Roman numeral in this parenthesis. Okay. So central metal ion, after that a Roman numeral in the parenthesis. One example is given here, hexacyanidopherrate. Here the oxidation state of central metal ion, that is ion Fe3 plus. See, the metal ion is written, following that a Roman numeral enclosed in square bracket represents the oxidation number of the central metal ion. That means the charge of the central metal ion, that is ion Fe3 plus. Okay. Students, we are going to find out or determine the oxidation number of central metal atom in the complex. Okay, an example is given, potassium hexacyanidopherrate. Here counter ion is K, potassium. The complex ion is hexacyanidopherrate. We can see potassium is denoted by a subscript, right? That is 4. So this 4 should be written as a superscript in this complex. So 4K plus ion and FeCN6 4 minus ion. We are going to determine the oxidation number. Oxidation number of what? The central metal atom. What is the central metal atom here? Ion Fe. Okay. So for that, the following step. Let us take the oxidation number of central metal atom as X. Okay, Fe ஓட oxidation number என்ன செய்றோம் தெரியாது, அதனால X ன்னு எடுத்துக்கிறோம். So how many ligands are there in this complex? There are 6 ligands. What type of ligands they are? Monodentate ligands. What is ligand here? Cyanide. So 6 monodentate cyanide ligand is there, right? Next, what is the charge of this coordination sphere or coordination complex? That is -4. Next, the number of monodentate negative ions. எத்தனை negative ions இருக்கு? 6 cyanide ions, 6 cyanide, அதனால 6. Okay. Next, now what you are going to do? The coordination sphere la என்னெல்லாம் இருக்கு பாருங்க. Ion Fe, that should be taken as X, plus Fe எடுத்தது என்ன இருக்கு? Cyanide. How many cyanides? 6 cyanide. Cyanide ஓட charge -1. The net charge எவ்வளவு? -4. So next what do you do? 6 1 is -6 ஆகும். So the -6 என்ன ஆகுது? அங்கே போகும்போது +6 ஆகுது. So the difference between -4 and 6 is +2. So the charge of central metal ion or the oxidation number of the central metal ion is +2. Okay. Likewise, we can determine the oxidation number. See some more examples we can see. The first one is potassium trisoxalato ferrate. So here the counter ion is K. So this complex can be dissociated into K plus ion ஆவும், the complex compound that is trisoxalato ferrate ஆவும் dissociate ஆகுது. Okay. So இங்க oxalato or oxalate ion is a bidentate ligand. That means they can capable of donating 2 lone pairs of electron to the central metal atom, to that is iron. Okay. அதனால oxalate is a bidentate ligand. The charge of this oxalate is -2. The charge of this oxalate is -2. Okay. So shall we calculate the oxidation number? Let us take the oxidation number of iron as X. So X, the coordination sphere பாருங்க, X plus எத்தனை oxalate இருக்கு? 3 oxalate. ஒரு oxalateக்கு -2. So 3 -2, 3 2s are 6, -6 is equal to -3. The net charge is what? -3. X minus 6 is equal to -3. So the -6 அங்க போச்சுனா +6 ஆகும். So X, the difference between -3 and 6 is +3. So the charge or the oxidation number of central metal ion Fe 3+. Fe is what? 3+. So the next example is sodium hexachloride cuprate. So here copper is given as a central metal ion. So we know chloride ion is a okay. In water, how it dissociate? The chloride ion is a unidentate ligand, Cl minus ion. Then oxidation state of copper we do not know. So let us take this copper as X. So the complex la enna irukku parunga, copper and 6 chloride. Okay. So X plus 6 minus 1, charge of copper is charge of chloride is -1. So the net charge is what? 4. Okay. Now 6 minus 6 into -1 is -6. So this should be taken to the next side. That is -4 and +6. The difference is +2. The copper oxidation state in this complex is +2. The oxidation state of copper in this complex is what? +2. Likewise, the next complex, that is sodium dicyanide-argentate. Sodium dicyanide-argentate can be dissociated into sodium plus ion, and dicyanide-argentate is a complex ion. There is only one sodium atom is there, so the complex you write -1 as superscript. So here cyanide is a unidentate ligand, so the charge of cyanide is -1. Oxidation number of silver is taken as X. The oxidation number of the element which is present in the coordination entity, that is X plus 2 minus 1 is equal to -1. That is X means silver, 2 cyanides, so 2 cyanides oxidation number is -1. The net charge is -1. Okay. So now the difference is x is equal to what? This minus 2 into minus 1 becomes minus 2. So uh, this minus 1 plus 2. The difference is what? Plus 1. So the silver in this complex, the oxidation number of silver in this complex is plus 1. The next terminology what we are going to study in this homoleptic complex and heteroleptic complex. What is homoleptic complex? We know what is complex, right? Complex consists of a central metal ion and ligands. See, in the central metal ion is surrounded by 4 or 6 same type of ligands, means that complex is called as what? Homoleptic complex. Right? In this module it is given one example, two examples are given. See, hexamine cobalt 3 plus ion. Here, being a central metal ion, this cobalt occupy the central position of this complex, and 6 amine groups are located in 6 different position of this central metal ion. So 2 ammonia occupies above the plane and below the plane. 4 are occupying 4 sides of the square. Likewise, the second one is hexacyanidopherate is an anionic complex. So here iron occupying the central metal atom, occupying the central position of this complex, and cyanides are 4 corners. Remaining 2 cyanides occupying above the plane and below the plane. So such kind of ligands, you can see all these ligands are same type. So this complex is called as what? Homoleptic complex. Okay. The next one is heteroleptic complex. What is heteroleptic complex? Heteroleptic complex is one which a metal is bounded by more than one kind of ligands. More than one means 2 or 3 type of different ligands are surrounding the central metal ion, means that complex is called as what? Heteroleptic complex. Okay. For example, here it is given. See, in the first example, you could see tetramine, bromo, chlorido, cobalt complex. Here you can see cobalt is a central metal ion. The amine is one type of ligand, chloride is another type of ligand, bromide is another type of ligand. So, 3 different types of ligands are surrounding the central metal ion. So, this complex is called as what? Heteroleptic complex. The next complex is tetramine dichloridochromium. See here, 2 different types of ligands are surrounding this central metal ion chromium. So this is one more example for heteroleptic complex.